AI networking hardware is now the linchpin for AI performance, boosting training speed significantly. Models train 40% faster now than they did in 2023, thanks to networking advancements. This evolution in AI networking defines the competitive edge in modern data centers. The journey begins in 2016 with 10 gigabits per second Ethernet as the norm. By 2021, data centers had adopted 100 gigabits per second to meet growing demands. The shift to 400 gigabits per second began in 2025, revolutionizing data throughput. Today, 400 gigabits per second interconnects are standard in AI data centers. These advancements allow AI models to process data more efficiently and quickly. This speed increase is crucial for handling the vast data AI requires. Such networking improvements also reduce latency, enhancing real-time AI applications. As AI models grow, so does the need for faster and more reliable networks. The evolution from 10 to 400 gigabits per second is a testament to rapid progress. It's clear that AI networking will continue to shape the future of technology. This evolution is not just about speed, it's about unlocking AI's full potential. As we look ahead, AI networking will be integral to future innovations. The next decade promises even more transformative networking technologies for AI. In AI systems, networking plays a crucial role in overall performance enhancement. Faster interconnects drastically reduce latency, boosting training times significantly. This is a major improvement compared to networking setups from 2023. NVIDIA's InfiniBand technology exemplifies the power of advanced networking. It offers high-speed data transfer capabilities crucial for AI workloads. Google's optical networks also highlight the shift towards faster interconnects. These optical networks enhance data throughput and reduce bottlenecks. Faster networking means AI models can be trained more efficiently. This efficiency translates into cost savings and faster deployment times. The advancements in AI networking are substantial, yet challenges remain. Complex network infrastructures require skilled personnel to manage them effectively. As networks evolve, the demand for real-time data processing increases. AI networking advancements are setting the stage for future innovations. These changes will redefine how AI systems are developed and deployed. In summary, enhanced networking is vital for maximizing AI's potential. AI models have grown exponentially, now reaching over 500 billion parameters. This massive growth requires advanced networking hardware for efficient processing. Distributed computing allows these models to be trained in parallel across multiple nodes. This approach reduces training time from weeks to just days. Advanced GPUs play a critical role in handling these large-scale computations. But even with GPUs, networking efficiency is crucial to avoid bottlenecks. High-speed interconnects are essential for seamless data transfer between nodes. Data centers have adapted to support the growing demands of modern AI models. They now feature specialized hardware configurations for optimal AI performance. Cloud computing further enables scalable AI model training and deployment. This scalability is vital for handling the increasing complexity of AI tasks. Moreover, efficient networking reduces energy consumption in AI operations. In summary, the growth of AI models is fueled by advancements in networking. These innovations ensure AI continues to evolve rapidly, meeting global demands. Edge devices have transformed AI networking by extending capabilities beyond data centers. With 5G, edge devices can process AI tasks 30% faster than in 2023. This speed boost enables real-time analytics for IoT applications. Advanced networking chips are key to this performance enhancement. These chips enable devices to make autonomous decisions at the edge. Real-time decision-making is crucial for smart home devices. Similarly, autonomous vehicles rely heavily on edge processing. The integration of AI in edge devices enhances efficiency in industry. In healthcare, edge devices enable faster diagnostics and patient monitoring. These applications require robust data security measures. 5G networks ensure low latency, critical for edge computing tasks. By 2026, edge devices are more powerful and versatile than ever. This evolution drives innovation across multiple sectors. As edge devices advance, they will continue to shape the future of AI. Their role in AI networking is pivotal for achieving real-time processing. Edge devices will lead the way in the next AI revolution. Investing in AI networking initially seems costly, but the benefits are substantial. The upfront costs are mitigated by savings in energy and efficiency. AI networking reduces energy consumption significantly, lowering operational expenses. This reduction leads to approximately 25% savings in costs over 3 years. AI networking also optimizes resource allocation, enhancing system performance. This optimization means systems can handle larger workloads efficiently. Additionally, AI networking reduces latency, improving real-time processing. Real-time processing enhances user experiences and application responsiveness. Over time, the efficiency gains outweigh the initial investment costs. Businesses see a 25% reduction in operational costs within 3 years. This reduction allows for reinvestment in further technological advancements. Moreover, sustainable practices contribute to a positive corporate image. In summary, AI networking offers a compelling return on investment. The initial setup costs are quickly overshadowed by long-term savings. AI networking is an essential investment for modern enterprises. In our connected world, securing AI networks is more crucial than ever. Data breaches can have significant impacts, compromising both privacy and trust. Current security protocols focus on encryption to protect data during transmission. Encryption ensures that data remains confidential and integral as it moves. Hardware solutions like encryption accelerators speed up this process significantly. These accelerators enhance security without compromising the speed of AI networks. Cloud infrastructure plays a key role in securing AI data exchanges. It's crucial to ensure that cloud providers adhere to strict security standards. AI networking also faces risks from cyber attacks targeting these systems. Proactive monitoring helps detect and mitigate potential threats early. AI systems are equipped with real-time threat detection capabilities. These capabilities allow for immediate response to any detected vulnerabilities. Ultimately, the goal is to maintain trust in AI networks through robust security. As AI continues to evolve, security measures must also advance. This ensures that AI systems can safely operate and innovate. The future of AI networking is being shaped by quantum computing and advanced AI models. Quantum networking could drastically reduce latency, enabling faster data processing. This technology allows AI systems to communicate in real time with minimal delay. As quantum computing matures, it might have the latency figures we see today. This acceleration will significantly impact AI research and practical applications. Quantum AI networks could transform industries by enabling real-time decision-making. Integrating quantum networking with AI is not without challenges, especially in scalability. Even with challenges, the potential to revolutionize AI applications is tremendous. Quantum networks could also enhance AI's ability to handle complex data sets. This advancement will open new possibilities for real-time analytics and insights. Quantum and AI integration may also drive innovation in personalized services. These advancements will likely require new infrastructure and investment in AI networks. Despite the costs, the benefits of faster, smarter AI networking are undeniable. As technology progresses, the integration of quantum networking will only expand. The next decade could see quantum networking as a cornerstone of AI infrastructure. Ultimately, quantum networking promises to reshape how AI systems operate globally. To implement AI networking solutions, start by choosing the right interconnects. Consider the balance between cost and performance for each interconnect option. NVIDIA's InfiniBand is a leading choice for high-speed networking. Intel's Ethernet adapters offer a more budget-friendly alternative. Ensure compatibility with existing systems to avoid integration issues. Use NVIDIA's NCCL for efficient data transfer across multiple GPUs. Evaluate the scalability of your chosen solution for future needs. Balancing network latency and bandwidth is crucial for performance. Monitor network performance regularly using specialized tools. Real-time analytics can help optimize AI workloads efficiently. Budget constraints require careful consideration of networking investments. Leverage cloud-based networking solutions for scalable and flexible needs. Finally, ensure your network is secure to protect sensitive data. For AI practitioners in 2026, investing in high-speed networking hardware is crucial. This investment maximizes model performance and efficiency on a large scale. Thank you for watching. Subscribe for more insights into AI advancements.